This is the Honors Geometry exam review for Unit 1, Topic 2. Question number 8 says point A, -1, -4, is to be transformed to point A prime using the translation rule xy corresponds to x minus 3, y plus 6. What are the coordinates of point A prime? Well, all we really need to do is substitute in the values of point A into the coordinate rule. So we have x minus 3, our x is -1, so it's going to be A prime is going to be -1 minus 3, and y plus 6, so -4 plus 6. Well, -1 minus 3 is -4, and -4 plus 6 is 2. So A prime is going to be the point -4, 2. Question number 9 says, triangle ABC has been transformed to triangle A prime, B prime, C prime. State in words the transformations that produce triangle A prime, B prime, C prime. Well, what we can see is that with this, point A moved 1, 2, 3, 4, 5 units to the right and 1, 2, 3 units down. Point B moved 1, 2, 3, 4, 5 units to the right and 3 units down, and C moved 1, 2, 3, 4, 5 units to the right and 3 units down. Therefore, we can state that a translation 5 units to the right and 3 units down was what produced triangle A prime, B prime, C prime. So again, the transformation that produced triangle A prime, B prime, C prime was a translation 5 units to the right and 3 units down. Next, it asks for a function rule that represents this transformation. Well, we always start with x comma y, our original ordered pair, and it's going to correspond to something that we do to x. Well, we're moving 5 units to the right, so we're adding 5 to our x. And then what we're doing to our y is we're moving 3 units down. So we're going to have y minus 3. This is our function rule. Next question says, why must triangle ABC be congruent to triangle A prime, B prime, C prime? Well, we know that we did a translation. We moved it 5 units to the right and 3 units down. And translations are one of our rigid transformations. Rigid transformations preserve size and shape. So again, triangles that undergo rigid transformations preserve size, meaning the distance between the points doesn't change, and shape, meaning the angles don't change. Therefore, the triangles are congruent. Finally, on the coordinate plane above, sketch the reflection of triangle ABC across the x-axis. Label the triangle DEF and write the function rule for this transformation. So if we're going to sketch a reflection across the x-axis, we have to remember this is the x-axis, and therefore only our y values are going to be changing. So the function rule in general, let's start with that, is going to be xy becomes x comma -y. We can see that, for instance, with point A, we're going to reflect it. It's going to be the same distance to the x-axis, so 1, 2, 3, 4 units. So therefore, we're going to be 1, 2, 3, 4 units below the x-axis. And that's going to be point D. Since we can see with what they're asking, A is going to correspond with D, B corresponds with E, and C corresponds with F. We can also see this if we use the rule. A, which is the ordered pair -3, 4, is going to correspond to D, which is going to be the ordered pair -3, -4. B, which is -1, 0, is going to become E, which is -1, 0. So since this point is on the x-axis, it is not moving, and that is going to be point E. Finally, we have C, which is point -4, 2, and that's going to correspond to point F, which is -4, -2. So we can see that C is going to be moving 2 across the x-axis to -4, -4, -2. And that's going to be point F. And therefore, we can connect our points, and we have triangle DEF. Question number 10 says, let XY be a point on the coordinate plane. Write the coordinates of the image point if XY undergoes the following transformations. So we're just going to be writing what the point in general changes to. And when we reflect across the x-axis, our x is going to stay the same and our y becomes negative. When we reflect across the y-axis, it is our y that stays the same and our x that becomes negative. So we're going to have the point -xy. When we translate 6 units to the right, that means our x is changing by adding 6, and then we're going to move 2 units downward, meaning y is going to decrease by 2. Now, D, E, and F deal with rotations, and I think rotations can be complicated and a lot of memorizing. But one of my hints that I love to share is to think about it in general and make a little coordinate plane. So what we know is that, let's pretend we always have a point and it starts in quadrant 1 and it's XY. Every time it moves to a quadrant next to it, the X and the Y are going to switch. So in quadrant 2, it's going to be YX. In quadrant 3, it's going to be XY. And in quadrant 4, it's going to be YX. And again, it doesn't matter which direction you go because every quadrant, it switches X and Y. Next, we can look at what quadrant it's in and determine what's positive and negative. For instance, in quadrant 2, my x's are negative, but my y's are positive. So this is actually going to be -y, x. In quadrant 3, my x's are negative, but so are my y's. Therefore, it's going to be -x, -y. Finally, in quadrant 4, my x's are positive, but my y's are negative. So I'm going to have y, -x. If I recreate this on the exam, then I don't need to worry about my different rotations because I can always base it off of this chart. Again, this is just something that helps me. You don't have to do it. But part D says rotate it clockwise 90 degrees about the origin. So that means in a general rule where I start with XY, I'm going to be going clockwise 90 degrees, so just one quadrant about the origin. Therefore, I'm going to have y, -x. If I rotate 180 degrees about the origin, and it doesn't matter what direction you go in because 180 degrees counterclockwise and clockwise are going to give you the same answer, you're going to go to -x, -y. Finally, if we rotate 90 degrees counterclockwise about the origin, we're going to be here, and that's going to give us -y, x. Part G says translated 2 units down. So if we do that, we've got our x, which stays the same, and y becomes y -2. We've translated 2 units down. And then we're reflecting about the x-axis, meaning our x stays the same, but our y's are going to become negative. What this means is that we're going to have x, negative of y -2. And if we simplify that, we're going to have x, -y plus 2. If you have x, 2 minus y, that means the same thing. Finally, we're going to reflect across the line x equals 1. To answer a problem like this, I like to visualize what's going on because I think that helps allow you to understand the problem better and therefore be able to replicate it with any type of problem, not just, the line x equals 1. So if I have a graph, I'm going to reflect it across the line x equals 1. So let's say we have a point over here, and the point is xy. We know a reflection means it's going to be traveling the same distance to the line of reflection and then again. So this distance, if this value right here is x comma y, we know it's going to be traveling to the line x equals 1. So this whole distance to the x-axis is going to be the distance of x, the x coordinate of the ordered pair. But we're actually not going to x equals 0, we're going to x equals 1. So this distance right here is going to be x minus 1. What we know is that if we reflect it, we have some point wherever it is over here, it's also going to be traveling a distance of x minus 1. Because it wouldn't be a reflection unless this distance was the same as this distance. Therefore, we know we're going to be traveling, this point's going to be traveling a total distance of x minus 1 plus x minus 1, meaning it's going to be traveling a distance of 2x minus 2. What we know is that a reflection is going to be starting at its point of xy and taking away a total distance from whatever this point is, a total distance of 2x minus 2. So we know our ordered pair is going to be x minus the quantity 2x minus 2. We also know nothing is happening to our y's. Don't forget to distribute. So if we wanted to, this is plus a negative and a positive. And therefore, our new ordered pair is going to be x plus negative 2x, which means negative x, plus 2, comma y. You could have also gotten 2 minus x, comma y, but either way, that's going to give us this new point, which is the point when xy is reflected across the line x equals 1. Question number 11, we're looking at part A. And it says to reflect the figure above across the line y equals 1. We're going to label the image A prime, B prime, C prime, D prime. So y equals 1 is a horizontal line right here. Y equals 1. So we know that we're going to be going a distance of 2 to get to y equals 1, so a distance of 2 away. So we're going to have a point here. This is going to be A prime. Same thing with B, we're going to have B prime here. And then for C and D, we're going to be going a total distance of 4 to get to y equals 1. So a total distance of 4 to get to the new point. So C prime is going to be right here, and D prime is going to be right here. And therefore, we can connect the points. And we've got our new image. Sorry that it's not as nice, but we've got our new image, A prime, B prime, C prime, D prime. Part B says, does this transformation preserve lengths and angle measurements? Justify your answer. Well, we know that we did a reflection, and a reflection is a rigid transformation. Therefore, we know that it preserves lengths and angle measurements because rigid transformations preserve size and shape. So again, the transformation is a reflection, which is a rigid transformation. Rigid transformations preserve size, so that means the length between 2 points, and shape, which means the angle measurements. Part C says if the figure was reflected across the x-axis, then translated 2 units upward, would the result be the same as the transformation in part A? Well, let's look. If we reflected across the x-axis first, A prime would be here, B prime would be here, C prime would be here, and D prime would be here. Because we're now reflecting across the x-axis, so a distance of 1 on either side, a distance of 3 on either side. But then if we translated that figure 2 units upward, we can see that 2 units up, 2 units up, 2 units up, 2 units up. Therefore, we have our original A prime, B prime, C prime, D prime figure. So yes, it would be the same. Question 12 asks, write the 3 rigid transformations. Well, the 3 rigid transformations are translation, rotation, and reflection. These are the 3 different transformations that preserve size and shape. What we learn about in Unit 2 is dilations, which keeps the shape but not the size. Question 13 says, if a figure undergoes a rigid transformation, then the transformed figure must be blank to the original figure. Well, as we just said, rigid transformations preserve size and shape, so the transformed figure must be congruent to the original figure. Question 14 says, look at the figure below. Complete each statement such that each transformation will map the figure onto itself. Well, we've got a reflection across the blank axis or the line x equals 1. Hopefully you can see that if I reflected my figure across the x-axis, I would get the exact same figure again. So we know that we're going to reflect across the x-axis. Additionally, if I reflected across this line, we can see that this part with a blank space will go into this. This part here with a blank space will reflect onto this one. So this is the line x equals 2. So we know that that's going to be the other reflection where it will map the figure onto itself. Finally, we talk about a rotation. And if we're going to get the figure to map on itself, we almost certainly know that we're going to have to rotate it 180 degrees. So it's hard to visualize this with what I'm using, but you can kind of see that if I take this figure and rotate it 180 degrees, I'd have my arrow here in the big box, and then I rotate it again, I'm going to have it mapping onto this one, and vice versa with the other one. Doesn't matter which direction I go, but it's going to be 180 degrees about this point at which they map, at which they share. So the important thing to know is that this point's got to map onto itself if it's going to map the figure onto itself. Therefore, the point's going to be at point 2, 0. Question 15 says triangle ABC undergoes a transformation to produce triangle A prime, B prime, C prime. The triangles are shown below. Part A says, can the transformation above be performed using a single reflection? Justify your answer. Well, we can see that A goes to A prime, B goes to B prime, C goes to C prime. And if we look at our points, we know that A is at 2, 4, B is at 2, 2, and C is at 4, 3. A becomes A prime, which is 2, negative 4. B becomes B prime, which is 2, negative 2. And C becomes C prime, which is 4, negative 3. When you look at these ordered pairs, you notice that the x's always stay the same and the y's are becoming the opposite. Therefore, that tells us that it's going to be a reflection over the x-axis. So it would be a reflection over the x-axis, which would mean the image of point xy becomes x negative y. Part B says, can the transformation above be performed by a single translation? Justify your answer. Well, it looks like this figure can be translated down, but the problem is that the corresponding points do not match up. For instance, A, if I translated it down, should match up with this point, but that's B prime. B would then match up with A prime. But it does work for C and C prime, but it's got to work for all of them for it to be a translation. So points A, B, and C do not translate to points A prime, B prime, and C prime. Point A moves down 8 units, point B moves down 4 units, point C moves down 6 units. Had the figures not been labeled, then you could say that the transformation above could be performed by a single translation. But remember, corresponding parts have to match up. Part C says, determine a transformation with 3 reflections that will produce triangle A prime, B prime, C prime. Well, one of the ones we could do is we could reflect it across the y-axis so that we have a triangle like this, and then reflect it across the x-axis so we have a triangle like that, and then reflect it across the y-axis again. We could also reflect it across the x-axis 1 time, and then back up here to 2 times, and then back down here for 3 times, so 3 consecutive times. I also could reflect it across the x-axis, so I'd be here, and then reflect it across the y-axis, so I'd be here, and then reflect it across the y-axis again, so I'm back at A prime, B prime, C prime. So again, we could reflect, take our original pre-image, reflect across the y-axis, then reflect across the x-axis, and then reflect across the y-axis again. Or we could take our pre-image and reflect across the x-axis, then reflect across the x-axis again, and then reflect across the x-axis a 3rd time. Or we can take our original pre-image and reflect across the x-axis, and then across the y-axis, and then across the y-axis again to produce triangle A prime, B prime, C prime. Question 16 says the line y equals 3x minus 2 is graphed on the coordinate plane below. We're going to write the equation of the line if y equals 3x minus 2 is A, reflected across the x-axis, B, reflected across the y-axis, and C, translated 3 units to the right and 1 unit up. One way to solve all of these problems is to take the original points on the line, ones that we know, like this one, and this one, and this one, or this one, and do the actual reflection or translation, and then write the equation of that line. So that's definitely one way, but I'm going to show you how to do it using algebraically, I should say, so that you can apply it to any situation. When we have reflect across the x-axis, we know our points are going from xy to x negative y. Therefore, if we have y equals 3x minus 2 as our original equation, all we're doing is making our y negative. Our x is staying the same, but when we write our equations, we need y to be solved for, so we're going to divide everything by -1, or multiply everything by -1. And we're going to get y equals negative 3x plus 2. So we can see that graphed, we're going to have 2 is our y-intercept, and I'm going to do rise over run down -3 and to the right 1. Down 1, 2, 3, to the right 1. I can also go from the y-intercept and go up 3 and to the left 1. But what that gives us, is a line that looks like this. So this is our graph for part A. Our next one is we're going to reflect across the y-axis. So this means that xy is going to become negative xy. Nothing is changing except for our x. So if we start with y equals 3x minus 2, the only thing that's changing is our x is becoming negative. So y equals negative 3x minus 2. That is the equation of our line. And if we graphed it, so if we did it by reflecting our points across the y-axis, this point would stay the same. This bottom point right here would come over here. This point right here would reflect over here, and this point would reflect 2 over. So what we'd have is these points, which would then form our line with arrows, and that's for part B. Part C is the hardest. We're going to translate 3 units to the right and 1 unit up. The first way I'm going to show you is using the points, because that might be the easiest. So let's say I take this point right here. I'm going to be moving it 3 units to the right, so 1, 2, 3, and 1 unit up. So I'm going to have a point right here. So this tells us that 0, negative 2 is going to become 3, negative 1. We can also see this because any point xy is going to become x plus 3, y plus 1. Well, we know that by translating it 3 units to the right and 1 unit up, our slope is not going to change. Our slope is still going to be 3. We have y equals mx plus b, and I know one of my points is going to be 3, negative 1. So I can plug in that point. I can substitute in for y, negative 1. I can substitute in 3 for m, 3 for my x, plus b, and solve for b. So negative 1 equals 3 times 3, which is 9, plus b, subtract 9, negative 9 and negative 1 make negative 10, which equals b. Therefore, our equation would be y equals 3x minus 10. So we know that we're going to have a point. This point is going to move 3 units to the right and 1 unit up. So we also know we're going to have a point here, and we can graph this line. This is going to be our part C. However, I do want to discuss another way of solving this. If you think back to algebra, and in algebra, we learned that we had an equation in vertex form of y equals a times x minus h plus k. We talked about vertex form when we had quadratics, so there was a square here, but then you learned in Unit 5 of algebra that any function, you could have a square root, a cubed root, any function could go with here. But because this is linear, our exponent's going to be 1, and we're given this. What we know is that xy is becoming x plus 3, y plus 1, because it's translating 3 units to the right, the plus 3, and 1 unit up. We also know that a is our slope, so we know that we're going to have y equals 3 times x minus h plus k. Well, what we know is that this is our horizontal translation and this is our vertical translation. We also know that our original equation starts at minus 2. So not only are we going to have a plus k of some sort, but we know we're starting at negative 2. So we start at negative 2 and we're adding some kind of k to create our new equation. With the 3x, we're not going to put anything in here. We just know we've got the 3 on the outside, and x, we're going to just translate it 3 units to the right. So y equals 3. Remember, 3 units to the right means x minus 3, because it's always the opposite. And then our k is going to be adding 1. So remember, we started with negative 2, but we're going to be adding 1 to that. So y equals, distributive property says 3x minus 9 minus 2 plus 1. And this simplifies to y equals 3x minus 10. If this was too confusing for you, don't worry about it because you can absolutely do it this method and this might make a lot more sense. But I just wanted to show you this method as well because it does work and it might be helpful to relate it back to algebra that you learned. And that ends Unit 1, Topic 2.